Hi guys, this is me, Subhashni and Shreya. As a team, we've brought to you the next part of Python coding, which is after standard logical operations that we've already seen in the video before. This part deals with Python data structures, lists, tuples, dictionaries, and sets. These are extremely important because they allow our reiterative repeating codes to work smoothly and allow us to save our data in certain structures for further processing. So, as you remember in the last class, we had looked at the fact that we can actually do arithmetic operators on a string. So, if we, especially all the positive or the operators which lead to an increase in value, okay, so that is addition and multiplication, we can use it on strings also, and it gives us exactly what we want. So, if we say the string into 3, it will actually print out the string 3 times, right? Yes, you want further details, you can always subscribe to the classes. You can reach me. My mobile number is given below. Now, what is important for today's session is the fact that we are looking at lists and which is a collection of objects which could be of string or number or special characters, and they could also be a combination of any of these. The part is that it has an index starting with 0, which means that you can actually order it. You can also place new elements in the list at certain positions or delete certain elements from certain positions. So I'm creating a list which has some fruits of my choice, apple, banana, and cherry. And you will realize that I'm putting a square bracket. So how do you know it's a list? When you see these square brackets. Now, what is this list? How long is my list? The length function works here too. And I find that my list has 3 values. If I want to pick out only the number 1 and number 2 value from the list, okay. So you remember the index, right? So apple will be 0, banana will be 1, cherry will be 2. Anything post cherry will be 3. So you will notice I put out 1 is to 3. Now, in a slicing position, the last value which is put into the code is not seen by the Python. So 1 is to 3 will lead you a list of 1 and 2, which is banana and cherry, from the back, because the index from the back starts with a -1 and not from a -0. So you can see if I want just the last value, cherry, I can write my list -1. Okay. There is another thing that you might want to understand is the concept of range. If you want to create numbers, right, you can actually put out a range, and the range would actually be mean from 0 till the maximum value of the range. So here you might see I've put a is equal to range 5, and when I do a, I get 0 comma 5. So if I want to put a number list saying 1 2 3 4 5, yes, I can do that too, and the same thoughts work for the number list as it works for the non-numeric string list. Now, the best part is to add values to a list. I can use an append function. So if I just look at the number list now, I will see 1 2 3 4 5 6. It has appended the sixth value, the 6 as a value into the list. Now, I will request you at this point to just pause and check. Can you add your favorite fruit into the fruit list or your earlier list if you've not created this fruit list? So here you go. I had created a fruit list. How would you add value into that list? Go ahead and try it out. Okay. Now I've had questions where people have asked me, can we insert things at a particular point? Yes, we can. So here I would like to insert at the 0th point, right at the start, 42, while at the 4th position, which is 0, 1, 2, 3, 4, actually the 5th value, right? If I was to count from 1, I will want to see 42 and 421. Okay, so here you go. You can see that 42 got added here, and now what we want to do is to add 421, which becomes 42 is 0, 1 is 1, 2 is 2, 3 is 3. and fourth is 421. Okay, so at the fourth position you have 421. If you want to remove anything from a list, you can always pop it. So I want to pop the last value, last position of the list, and here you can see the list was 8 values long, it has now become 7 values long. Okay, can I create a new list from the existing list? Yes, I can. The way to do it is through slicing, where I say new list is the existing list from point 1 is to 3. That means 1 and 2, 3, of course, being the last value, will not be included. Now, there is, of course, a very simple thing. Python is a English-like language. Hence, you find that you can just use the sort function to get the sorting of a list. Here, I want to do a reverse sort or descending sort. So I just put num list, that is the name of the list, dot sort, reverse is equal to true. Okay. If I had not done this, then I can just enable this and put this out, and then you will notice it is ascending sort. Ascending sort is the default sort value. And if I want to see all the values of a list together, I can actually say print the first list plus the second list. So here you go. I say print the first list, num list, plus my second list, which is my old list of banana, apple, and cherry. And here you get all of it, right? If I wanted to create a new list also, I could have done the addition function. And here you will notice that there is a new list. Okay, new list one, new one, and it has all the attributes of the number list as well as the fruit list. And the same list I could also do an into. So again, I'm demonstrating that arithmetic operations would work very well on the list, just the way they worked on a string, and I will get the same list 3 times. Okay, so go ahead. At this time, I will request you, go ahead, create a list and try out these functions. The next distinct different type of selection of attributes comes from dictionaries. So dictionaries have key and value pairs and no index. Why would you need dictionaries? Today, a lot of the data in the world is actually in written form, PDFs, reports, people speaking and that getting converted to, written form for further understanding. So you need an index, a no index driven dictionary to convert the words into words in a different context. So you even if you look at English, which is pretty much a common language across the business world, you will find that the way certain words are written in UK versus US are different, right? So you do need a dictionary to convert the key and value pairs. Just the way you have a normal dictionary where you have the word and then you have the meaning. So in this dictionary, how does it differ from a list? One is the key and value pair, and the second is this curly bracket. So a curly bracket tells you that this is a dictionary. In this dictionary, we have written that brand. If the word brand is mentioned, you assume it to be Ford. If model is mentioned, please take it to be Mustang. And if year is mentioned, take it to be 1964. Right? There are two ways to distinctly write out information you can see here. And the fact that you cannot have a duplication in keywords. So here in the second box, you can see I have put year is 1964 and year is 2020. And when I see it, it actually just shows me the last key value pair for that key word. How could I have otherwise done it? I could have put year 1 is 1964 and year 2 is 2020, and then it would have accepted two different key and value pairs. Okay. So just like a list, just like a string, the length function and the print functions work exactly the same for dictionaries. Okay. And how do we figure out or call for information about dictionaries? First thing is figuring out if a list of values or a table is a dictionary. When you type out saying that print the type of values, it will tell you it's a dictionary. And the second thing is you can assign values. X is equal to model. Then when you say X, it will give you the value pair. So what have you done? You have pointed to the key and it has given you the value. You have pointed to the key called year and it has given you the value called 1964. Again, adding into the dictionary is actually easy. You can do add in color with the key and value being white. And all you have to do is this dictionary color is equal to white and run it. And here you will notice that you have added in a value into the dictionary. Okay. You can also check out only the keys over here, like brand, model, and year. And if you want, you can also check out only the values, just like English. So, yes, whatever you write in the English, that only you can use here. Okay. Now, the third type of aggregation is called a tuple, which is nothing but a non-mutable list. Okay. So, yes, you can replace the values. You can replace a tuple with another tuple, but generally the list will be non-mutable. You cannot add or subtract. Okay. So, here you go. Why would you want this? You would want it to ensure strict control that nobody comes and changes the options in your data set or in your app, right? Or your website. So here you go. If you the tuple is different from a list in terms of being having this curved bracket, okay, and all the functions of length etc. will work in a tuple. It can also have mixed values just like a list, okay. So that is there. The only thing is you cannot add into it, you cannot subtract from it, no append, no insert, no pop, okay. If you were to look at algebra, you can see that yes, you can do an assignment. So muscle is 2 plus 3, brain is 7 minus 3, speed is 5 into minus 4. And then if you say strangeness is muscle plus brain into speed, it will actually run it out in the BODMAS sequence and give it to you. Okay. The other way to write it would have been something like this. A is equal to 2 plus 3. So the assignment can be either to words or string, or you can, of course, do the assignment to letters. Right? Here you will notice 45 is not equal to. So do remember the not equal to function. We've done it earlier. There's an exclamation mark and an equal to over there. Right? And this is the not equal to function. It is again a Boolean function. It will give you true or false. Okay. Now, there is a fourth variant of types of data or structures of data, which is called a set, right? So here you will see that setting a set is like putting a tuple, putting a list within a tuple bracket. Okay, so set A is apple, oranges, bananas, apple, oranges, while B is avocados, mangoes, apples, grapes, oranges. Okay. So what do I get? I get a set. Now the set does not have an index. So there is no position argument related to a set. So dictionaries and sets don't have a position, but it allows us to do all we had done in our set theory in arithmetic, which is A union B, A intersection B and the like. So here is where we go. What is in A and not in B? We can do A minus B. Yes, arithmetic operations. What is in A and B? That is what is common, A union B. So apple is there. And which is in A, sorry, A and B is A intersection B. A slash B is either A or B. Okay. So that is A union B and you have all the values coming in. So sets are a great way to ensure that you can deal with lists, especially if you don't have any reason to retain the index. So with this, I'll stop this session and I look forward to seeing you in the next session.